Our monthly research and technology forum, and I see some of you may be new to the building, so we welcome you all to this month's program, which will be on stormwater management. And you see that there's a teaser here for next month's program, which will feature Carrier's recent work at the Sistine Chapel. So this will be our holiday presentation about technology and in preserving the art and treasures of the Sistine Chapel with energy efficient HVAC systems. But today it's my pleasure to introduce the moderator of this forum, Professor Khris Dodson. Cliff is the Thomas and Colleen Wilmot Professor of Engineering in the College of Engineering and Computer Science in the Department of Civil and Environmental Engineering. Also, he was recruited here from Carnegie Mellon University several years ago, in part, I think, because of the opportunity to interact with collaborators through the Center of Excellence. So Cliff is, when a faculty member comes to an institution, it's like a new faculty member. And Cliff has started like a second career. So he had 33 years at Carnegie Mellon, and he's come to Syracuse and established a great program, including research on green infrastructure. Cliff and his students have instrumented the green roof at the On Center, and are in collaboration with many of the parties that will present today. So without further ado, my pleasure to introduce Khris Dodson.
Thank you for that very generous introduction. It's really a pleasure to be here, and I think we have a very exciting schedule this afternoon. We're going to hear from three individuals who have done some truly pioneering work in the area of stormwater management. It's my pleasure to introduce the first of our speakers, who is Khris Dodson. Khris is the Associate Director of the Syracuse University Environmental Finance Center, and in that capacity he provides assistance to local governments here on topics related to environmental infrastructure, finance, and planning. He's also the Education and Outreach Coordinator for Onondaga County's nationally recognized Save the Rain program. Many of us have been involved with that Save the Rain program and know that in fact it's really an amazing program that I think has put Onondaga County on the map, and Khris is really to be commended on that. Khris has a master's degree from SUNY College of Environmental Science and Forestry, and he has a master's degree from Syracuse University. And also I have to give Khris a lot of credit, because he was the one who originally put us in touch with Matt Millay, who at that time was the assistant to the county executive, Joanne Mahoney, and it was actually that first meeting with Matt Millay that started some very interesting excursions, we can say, in cooperation between the Syracuse Center of Excellence, Syracuse University, and Onondaga County. And those collaborations continue right up to this day with a lot of projects underway. So with that, please let's welcome Khris Dodson.
Thanks, Cliff. That was an inspiring introduction. I am happy to be here today and present to you guys kind of an overview of Onondaga County Save the Rain program, to really serve as kind of background, but also helping you to better understand what some of the goals are of the program. And like I said, to serve kind of as background for the next two presenters today. So I call green infrastructure, which is the Save the Rain program, a truly public utility, because Save the Rain is really possible because of the work that happens on private property as well as public property. So by using a rain barrel or building a rain garden or building what Mike's going to talk about here on this project, capturing stormwater, we're actually serving the public good, serving the community that has to normally pay for, has to pay for the management of that stormwater. So by managing on the site, we're helping everybody. The alternative is for all of us to put in a few volunteer hours at the wastewater treatment plant every month, and none of us do that. We'd much rather pay our wastewater bill. So it's kind of, in my mind, if you think about it, it's a little bit of a turning utilities on their head when you think about green infrastructure and the service it provides to the community. But this isn't your grandmother's rain barrel. We're not capturing a couple of gallons of water in the backyard in a bucket to water some marigolds or some herbs. We're talking about hundreds of millions of gallons of stormwater. In Syracuse, we have to capture about 250 million gallons of stormwater a year. And that's just tiny little Syracuse. This is Syracuse. These colors are our mapped sewer sheds. So like some of us think of watersheds, this creek flows into this river, flows into this estuary, flows into this ocean. This is the same way that we think about our pipes. The pipe that comes off of your residential street goes into a trunk sewer, that trunk sewer goes into an even bigger conveyance, which takes that stormwater into the metro treatment plant to be managed. And Syracuse, like most cities, particularly in the last 50, 60, 70 years, kind of concurrent with the advent of the car, we've begun to pave more roads, more parking lots, but also more development, and different kinds of development. No longer do we have the 4- or 5-story apartment buildings like Boscov's and all these places that used to exist in urban cores, but now we all go shop out on the Strip, on Erie Boulevard or Fayetteville, where we have hundreds of square foot single-story buildings that we shop at with even larger parking lots that service them. All of those become conduits for stormwater that we all end up managing. And in our urban areas, that infill development has continued to make less and less pervious surface for stormwater to go through. So why is this important in Syracuse and 774 other communities like Syracuse? It's because our system, which was innovative when it was designed 100 years ago, to combine the sewer that comes from your house and the stormwater that comes off the street into one pipe, manage it at the end of the pipe where there's a wastewater treatment plant. That was innovative then. Today we know better. It's not good to put raw sewage untreated into a water body that in the days of valuing waterfronts as an asset, as a community asset, as an economic development engine or tool, you can't really create a waterfront people want to pay to be next to when you have literal crap floating down it, right? It's obviously also a public health issue. So this is why we have to think about managing stormwater differently. This is why Onondaga County is using green infrastructure. This is why a lot of other communities need to think about it too. Even if it's not a CSO, a combined sewer overflow community, if there's stormwater and their sanitary sewer travel through different pipes, we still have a lot of contaminants that hit the ground that end up ultimately in drinking water or in water bodies that could be drinking water supplies. If I'm in a third grade classroom, I might use the analogy of, well, when it's raining, you might stick your tongue up or look up to the sky and stick your tongue out and capture some raindrops. Would you lap out of the puddle once that raindrop hit the ground? No. Why? It's icky. Well, all of these things make the water, once it hits the ground, icky. Particularly the road salts, the fuel and the gasoline. All of our cars drip all the time, even if it's windshield washer fluid. The cigarette butts, the pesticides, even the leaves that are stacked up obnoxiously at the edge of the road that I live on in the city of Syracuse. 1 leaf, 2 leaves in a forest environment, sure, we've got it. Tons of leaves dumped into one single water body at the end of the pipe. Maybe now those nutrients have become to the level of a toxic pollutant, right? Zinc is good for us until you pop 2 or 3 of them in a day, and then you might have a problem. So this is why we're thinking of green infrastructure as a better way to manage stormwater. Also, it's less disturbing to the neighborhood. This is a 12-foot pipe being buried about 12 feet underground in a residential neighborhood in the city of Syracuse. It's tough enough sometimes to live in some of the communities we have in the city. It's even tougher when you wake up to the noise of this kind of construction. To move sewer from one end of the city to the other. And this is in the ground, in that same picture. So that's a full-scale piece of heavy equipment going into a 12-foot diameter pipe to service stormwater, to convey it from these trunk sewers into a new facility, which is this one, the Midland Regional Treatment Facility that was built on the south side of the city. So ultimately, Onondaga County, County Executive Joni Mahoney decided there's got to be a better way. These disturbances don't make for a livable neighborhood. They don't improve quality of life. The economic cost of this building, the economic cost of the continued operations and maintenance, which never gets cheaper, energy is never going to really go down, labor is really never going to go down, is going to be a burden on our community. Is there a cheaper way? Is there a better way? And so came the Onondaga County Save the Rain program. Fast forward to 2000, those questions were being asked in 2006, 7, 8. 2010, Save the Rain happened in earnest. And in 2011, we had our banner year, 50 projects in the ground, 50 large projects, some of which I'll share with you in a minute. But to step back, for those of you who may not know what green infrastructure is, this is what we're talking about. Rain barrels, rain gardens, bioswales, green roofs, and I couldn't find one of the on center. I wanted to give a little shout out to Cliff, but this is probably one of the first green roofs in the city, 2005 on Walters Hall, SUNY ESF. We've probably got about 24 green roofs in the city of Syracuse now. The largest one is on the on center. Cliff Davidson is monitoring that one. It is probably the most instrumented green roof in the world. It is cisterns, rainwater reuse, perhaps one of the best unrealized resources that we have is what falls from the sky. Porous pavements, let the water go through the pavement, into the ground, infiltrate into the groundwater. The New Hampshire Stormwater Research Center, for 30 years with NOAA money, has been demonstrating that this stuff works. If it's designed correctly, if it's installed correctly, if it's maintained correctly, this will last longer, has a better life cycle analysis than traditional paving materials. So why aren't we using more of this? That's a whole other hour. That was a rhetorical question. And it does cost a little bit more at the beginning, but this one paved strip of porous concrete services this whole impervious area of asphalt. So we don't have to repave the whole parking lot in porous to get the infiltrative or the storage properties. So a few program highlights, things that make Save the Rain cool, and then by extension make Syracuse cool, things that we can be proud of. This is the first community to get sued to use green infrastructure. Not really completely accurate, but this is the first consent judgment that we got green infrastructure written into. So Onondaga County, under the Clean Water Act, has to use green infrastructure. We have 170 projects complete. More than 80 of them are public-private partnerships, what I talked about in the beginning, having people with private property help reach those public goals. So far, we have 150 million gallons captured. We've done a lot of education, given away a lot of free rain barrels to city residents. The ACJ, or the amended consent judgment, requires that we capture only 6.3% of our annual CSO volume. That's like 250 million gallons. So you think about the other 97% and how many gallons that must be. We have benchmarks to meet. One of them is at the end of next year, 2015. I'm fast forwarding already. We also have to do monitoring and reporting, and we have to do public education. So we have to be able to demonstrate that we're doing what we say we're doing. And this is part of some of the great work Cliff Davidson and David Chandler are doing for the county. We're planting 8,500 street trees by 2018. Street trees drink water. Stormwater is water. Let's have trees do some of the work for us. We're also helping people do public or private projects on their property with public dollars.
'Dollars. So we have a grant program called the Green Improvement Fund. We have 170 projects complete. More than 80 of them are public-private partnerships, what I talked about in the beginning, having people with private property help reach those public goals. So we have 150 million gallons captured. This is the first community to get sued to use green infrastructure. Not really completely accurate, but this is the first consent judgment that we got green infrastructure written into. So Onondaga County, under the Clean Water Act, has to use green infrastructure. We have 170 projects complete.
This is not working. Oh, and we have a lot of different projects, which I'm just gonna, the last few slides are just pictures of pretty projects that we put in. And there's this is the green roof before Cliff's instrumentation went on it. Well, actually, your instrumentation is already under it, but some of it is also on it. This is a great example of a public-private partnership. The Jim Boeheim Foundation, I think you guys know who Jim Boeheim is. If not, Google him. But the Jim and Julie Boeheim Foundation, they have a Courts for Kids program. We leverage Courts for Kids program money, county money, and city parks money to rebuild five basketball courts in city parks to make them porous. Anecdotally, the neighbors around, so no more splashing in puddles, kids can go out as soon as it's done raining. And anecdotally, the neighbors around the basketball courts are like, it sounds a little bit quieter. I don't know why, but it doesn't sound as loud as it used to. No one's done any research, but I'd imagine it's because of the void space and maybe the diffusion of sound, but I'm not much of an acoustics guy. Connective corridor, if you haven't seen it or heard about it, we're capturing millions of gallons of stormwater a year. And again, another great partnership between Syracuse University, the city, really arguably the state, and the county. The ancillary benefits are a beautified roadway with more ADA accessibility, walkability, and bikeability. This is a before. Notice it's gray and rainy and dark and lifeless, and the after is sunny and bright and green. The engineers don't have a lot to do in winter, so they take pictures. But again, the ancillary benefits here might actually outweigh, if we were to do a quantitative analysis, the stormwater benefits, because this becomes a corridor that people want to travel through. People want to pay money to be around. And it may sound like a stretch on this particular corridor, but it's coming in Syracuse and in other communities where we see this green infrastructure as part of an economic development engine for some communities. All of these people are drinking beer, and all of them have to let it go later, and they're flushing it down potable water. I'm not a particularly religious guy, but I kind of think it's a sin that we use drinking water for these kinds of uses when there are people, even in our own country, who don't have access to clean water. So Syracuse University, maybe not for the same reasons that I would give, decided, hey, let's capture stormwater off the roof and use it to flush the toilets, really the troughs. And so they're doing just that, and I think maybe the project's complete. I'm not sure. But again, looking at rainwater as a resource that we can use for other reasons. The ice skating rink at the Syracuse Crunch Skate On, also rainwater. The cool thing here is it takes a little bit less energy to freeze rainwater than does potable water, something about total suspended solids. So they're saving incrementally on energy costs, and they're saving big on potable water costs. The zoo is also using rainwater to fill up their duck pond, which they have to flush every couple of weeks for cleanliness, saving tens of thousands of dollars a year the zoo is on potable water costs because of that. Parking lots in Syracuse and Onondaga County and upstate New York are the bane of everyone's existence because of the way freeze and fall happens, which, by the way, freeze and fall doesn't affect porous pavement the same way it does impervious. So we take this radial parking lot and make it into a stormwater utility. Turn it into something that takes water off the surface and puts it into the ground. And it makes it more attractive and more driver-friendly. We've done that a lot. Here's another one where this whole thing isn't porous, just the outside, but it manages the whole parking lot. This is next to the on-center, and then the on-center parking garage. While they're digging up the parking lot, why not put in LED lights? I think this is Ephesus lights, and put in electric car charging stations. Thinking forward, people are asking for these things now. Killing a couple birds with one stone. Again, you notice that the before is gray and lifeless, the after is beautiful and sunny and green, but just putting this in, it makes it more attractive and it captures stormwater. So scaling, or looking back at the 30,000-foot view, this is capturing stormwater, this is capturing stormwater, capturing, capturing stormwater. So from this one shot of Syracuse, we're really beginning to make a major difference in how we're managing stormwater. A couple of other pieces, we have the Save the Rain Barrel program I mentioned, and we're having fun with it. It's a PR tool. It gets people to understand why Save the Rain happens, how they can get involved, and why we're raising their sewer rates. And you know, painting them, doing these at art, giving them away at art events is a nice touch. Demonstration projects, putting it in front of people's faces. This is a community center on the south side. This is the before, and it's really not purposeful, but again, it's kind of gray, and here it is sunny. But with the rain gardens and the rain barrels. I wish I had more time to talk about the Onondaga Earth Corps. It's a really wonderful story of employing these kind of at-risk youth in Syracuse to design and install and maintain green infrastructure and teach their peers and their parents about it too. Another porous concrete installation on the residential driveway. This is one the Syracuse Center of Excellence in 2009 had provided a lot of support for at 515 Tully Street. This is the before and the after. Across the street from a park, catty corner to a school, a lot of pedestrian traffic, a lot of people walking by, being like, whoa, what happened here? What you don't see is the sign that we put in afterwards saying, this is what happened here. And this is that same rain garden doing its job after that major storm we got in April of 2011. Remember, we got like 2 inches in half an hour, flooded the downtown part underneath the highway. So, you know, another ancillary benefit, this is my touchy-feely end, is that, you know, Save the Rain can really bring people together, these public-private partnerships, bringing sectors and groups and agencies that don't normally work together, to get them to work together on projects like this rain garden. We had a number of different stakeholders work on that rain garden. And bringing in different assets from the community, the Onondaga Earth Corps, these youth that are building and maintaining these projects. Researchers at Syracuse University that are helping the county justify or demonstrate that we are getting the volume control out of these projects that we want to get. And then, of course, our elected officials, Joni Mahoney, the EPA Administrator Judah Fink, and Mayor Stephanie Miner, all interested in this program from their varying perspectives. One last thing is, you know, Syracuse is really being looked at as an innovator for green infrastructure. We're doing great things here. Other communities are looking to us as an example, as a leader, and that's something that we should be proud of. And to demonstrate that, we had 70 people from about 40 different cities from across the country attend a summit here, the first one last fall. The second one was just 2 weeks ago in Cleveland, the National Green Infrastructure Summit. So that's me. If you have a couple of questions, I might have taken a minute or two longer than I should have, but anything? Otherwise, I'll yield to the moderator. Yes?
Khris, that was a great presentation. Thanks very much. I want to go back to your quick comment about the amended consent judgment where you said quickly that the county was sued to put in green infrastructure. So I offer an amendment to your characterization. So the county long ago was sued under the Clean Water Act by Atlantic States Legal Foundation.
Yep.
And there was a consent judgment, an original consent judgment. And then later it was amended, and I think later after that was amended again. And under those amendments, as you surely know, the plan was to build regional treatment facilities like the one at Midland Avenue that you showed in the presentation. And when Joni Mahoney was elected county executive, one of the first things she had on her desk was to approve the construction of another regional treatment facility that was going to be built in the trolley lot. And she stopped that train in its tracks, and she asked for the amendment of the amended consent judgment to include green infrastructure with the consent of the original plaintiff, the Atlantic States Legal Foundation, and the Onondaga Nation. So
Yes.
it was really a community effort that asked for a revision. So the county, in partnership with the United States, actually asked that the consent judgment be amended yet again. So just wanted to give that, like the county wasn't sued to toll the green infrastructure. The county requested the revision of the amended consent judgment to ask for that. So
No, that's
now,
absolutely.
now you get to amend what I just said.
No, I mean, Ed's entirely correct. I was trying to zip through, so I glossed over the words probably. You never gloss over legalese as quickly as I did, so that's completely accurate. Yep.
And really, I think the whole story is just amazing. I think locally we tend to take it as, this is just the way things are done. So I don't know, maybe Cliff coming from outside of the region. Cliff was coming here from Carnegie Mellon right about the time that all of this was happening.
That's exactly right, and I don't want to take away time from our speakers, but let me just mention that in Pittsburgh, the Allegheny County Sewage Control and Stormwater Control Authority, ALCASAN, had a completely different attitude. And despite a lot of efforts by several individuals at Carnegie Mellon and University of Pittsburgh to, in fact, have green infrastructure be a major set of installations in Allegheny County, it never happened. And the reason that it never happened is because of the very conservative leadership that was present in Pittsburgh at the time, in Allegheny County. I think that Ed and Chris are both right on target when they say that what we have in Syracuse and in Onondaga County is really some tremendous leadership on the part of the county, on the part of the city, on the part of the academic institutions, on the part of the Center of Excellence. I think that we are seeing a difference in Syracuse that you would not see in almost any other city. There are a few other shining bright spots around the country where green infrastructure is being studied and is being installed, but in fact, on a per capita basis, I think that Onondaga County is still the leading county in the country in terms of the number of green infrastructure projects per capita. So I think that speaks volumes about the leadership that we have here. And I think that what Chris has described is a really nice overview of why that is the case, why it is that we have the privilege of living in a county that is, in fact, one of the clear national leaders in stormwater management. So thank you, Chris. Okay, I think in the interest of time, we'd like to move forward, and it's my great pleasure at this point to introduce Mike Lasell. Mike has 10 years of professional experience concentrated in the area of civil engineering. He is a project associate with O'Brien and Gere, and he's currently responsible for a number of the projects, particularly those that are multidisciplinary, that O'Brien and Gere has, not just in New York State, but in several states. Mike has been a key person in stormwater technologies, and in particular, been one of the lead individuals in the Green Infrastructure Initiative for his company. He's worked closely with the regulatory contacts within different state agencies, and he's worked to create the most effective and economical stormwater approaches for several specific sites. So let's turn the floor over to Mike Lasell. Thank you.
Afternoon. What I want to go through here is really what we worked on this particular project here at the Center of Excellence for this Intermodal Transportation Center for this parking lot. Actually, it's right outside. It's not built yet, but it's scheduled to be built here in coming months. I think Chris did a great job. He did a quick overview with a lot of the projects that are happening in this area. They're all fantastic projects. This project started, I think, 3 years ago now, 3 to 4 years ago is when we started this. It was right at the beginning of that Save the Rain thing, the Save the Rain era where there's a bunch of the engineering companies were really starting to try to grasp what we could do to kind of follow that lead and to kind of help support that. There wasn't a lot of direction at that point. There was, a couple projects going on. That's when it was the first year that all those big projects started. And a lot of the engineering firms were kind of following into that and see how we could help support that. So this project started out saying, how can we help support the initiative? And we kind of follow suit, and it makes sense. So I just wanted to go through the specifics on this project with a quick overview of how we approached trying to help reduce runoff and help the CSO sewers. So just a quick 4 points, with this site, I don't know if everybody's aware of it, it's a site that's out here right next to the building that's kind of empty right now. it's going to be a parking lot, but it's more of a parking lot. It's an intermodal transportation facility that's tied to the DOT that kind of acts as a place for the connected corridor to be able to park your vehicles. If you have a bike, there's going to be a little shed there that's kind of this innovative building that houses direct bikes or kind of connected corridor. So challenges on the site, we can talk about the design requirements that we were kind of boxed into, and then the approach that Gere came up with to help follow the suit of the Save the Rain program. Then lastly, we'll look at maintenance and monitoring. And I think it's great that you're here because we haven't really gotten into that. We're doing the stuff that the DEC requires in kind of the city of Syracuse, but I think you can go above and beyond that to really learn from this thing. And I think that's what the main purpose here today is, to try to figure out how we can learn from this and keep making it better. So quickly, just looking at the site, we're in this building here, and most people probably came in this way, but this is that area that's kind of nothing right now inside the fence. So you can see the parking lot that we were proposing, and then the challenges that we faced in this particular site. Obviously, looking for a 100-car parking lot, not a lot of space out here. They didn't have a lot of room to place large stormwater basins or anything like that. Another bigger issue is the impacted soils. The entire area on the site, it has some impacted soils that we had to work around without costing more money without removing them. And then this tree as well is another big monument that we had to work around. You can see that picture on the right there. So that's something it's actually right here on the site. You can see it out there along the street as well. So those three things were kind of challenges for us to help meet the hope for the intermodal facility for the 100-car lot. Looking at the design requirements from the city of Syracuse, the New York State DEC, and then also in the back of our head, how can we help support the Save the Rain gains? There wasn't really a definition of what we wanted to capture for Save the Rain at that point when we started this. So with the city of Syracuse, they look at it and say, you're going to a combined sewer, we have to be able to meet a certain flow for a 10-year storm to meet their plumbing code, which is a half CFS per acre for a 10-year storm, is what I believe the number is. So we had to make sure, we have to slow down the water, we have to capture it and do something with it, hold it and let it out slower. That's the old way of things. And what can we do to hold it, use it, or somehow get it into the ground prior to letting it, or not letting it go. So that was the city of Syracuse requirements that we were following. We did have to follow the general permit for speedies. It's combined sewer, so they don't really have control over that, but that's another thing the city of Syracuse at that point was making us do for design requirement. And again, we know our design is for a 100-car lot with a building on the corner of it. So what we've come up with for an approach for stormwater, and looking back to this so you can see the edge of our parking lot, and kind of the area that we had to work with is out by the street along the new green infrastructure that's out there today. We had this strip that really made sense to try to utilize for stormwater. And looking at that strip, this is kind of a cross section of what we did there. Here's the intermodal parking lot. We had this room here, and then center line of Washington Street over there. So we had a significant amount of area. Again, we didn't want to go real deep because soils and the concerns of the soils. So we looked at what the potential was that we could do in this area. And the other issue was impacted soils. We didn't really want to infiltrate a lot of water down. So we had to look at how we can get rid of water without infiltrating. And the best thing of that is planting soils and evapotranspiration and kind of a system like this. So how this works is we're taking water really just from our site. At first we were looking at taking water from Washington Street, but as you can see the improvements that happened out there, that was pulled off the table. Now we're just really looking at our water. So you can see the soil media, 18 inches. And then this underground storage system, kind of proprietary features called Stormwater chambers, that allow us to store water underground, out of sight, and in kind of a bigger footprint. So if we go back to this picture again, that's what these boxes are representing. So that shows that we can fit quite a few of these systems underground to help capture the water and hold it back, and then at the same time, we're trying to get rid of water. So we're uptaking it in the soil, and this is all plantings in here. So that kind of goes, so this is what I'm talking about. These underground chambers are what we've been using. But this top picture shows the tank right here. So when Center of Excellence was built, they had to meet, again, that plumbing code. So we were holding water back. So the tank was the best option at that time. But a lot of us, we were trying to not have to use a tank. We were trying to figure out how we could follow that safe rain scenario initiative. So we looked at possibly trying to collect the water that was in this kind of a basin, like the bioretention kind of acts that same way. So you can see what they were collecting for gallons of the tank. That's the tank size. And how big our area is. This is not just the chambers. It's actually chambers and all the storage here. So you can see significant gains in the gallons. Larger footprint, but not as deep, and it made sense to put it where we put it because there wasn't really additional parking we could fit in. So kind of from there we needed to say, okay, we got our system, and then we wanted to really see just this header pipe here is what we tie into this kind of open basin here. I know I'm jumping around a lot, but I need to plan at the same time. That's right here. This basin right here is this section here. So we have all this water coming into here that gets through our system, and we want to be able to monitor that. What, with the rain that we're getting, how much is getting through, and how much are we taking in here, and then we're controlling that through a small outfall here, and it continues on there. So it's a cross section. This is our outfall pipe right here. But that's what I wanted to look at. What we can do to help monitor what we're dealing with here. I think there's a lot of opportunity inside of this, capturing the rain, or figuring out how much rain is falling, and doing all that stuff. So, I don't know if anybody had any questions or anything about this, or if anybody has any ideas, anything like that could help. You know, what potentials we have to monitor this stormwater basin. Anybody have any questions or anything? Yeah, go ahead.
Do you want to monitor so that you can look at what happened, or do you want to monitor in real time so you understand the status of storage?
I think we should monitor to mainly look what happened. I don't think we're going to change what we're doing here in terms of potential options, but I think if we figure out how this works, to kind of apply it to other projects is, I think, my intent. That's what I was.
What was the nature of the soils that you didn't want to just send it down through forced pavement or various other green infrastructure
Yeah, so
methodologies?
this is actually sealed. We have a liner in here, like you mentioned, but the problem is, it's an asbestos soil, and then there is other hotspots out there. So you can see this liner that's underneath our disturbed area. So infiltrating wasn't a real
So, I mean, it's contaminated soil that you don't want water
push,
removed.
to push out. Yeah, exactly.
Okay, yeah. Urban residue.
Yeah, further.
Okay.
the other things too, this is graded so we can really see what's happening. Yep, go ahead.
Are you getting any settling in that? Is that being part of the intent?
This last thing here,
Was the pre-treat?
so we're pre-treating pretty heavily. Obviously, we're trying to infiltrate anything that doesn't infiltrate in these larger storms comes through our grates. They're high, they're 6 inches up, so anything that's over 6 inches of water, whatever it is, comes straight into our storage chambers. And then we do have, it's hard to see, but right here, all the water comes into this, it has to leave through one orifice, and it's got a trash rack on it, and it's lifted off the bottom, but we're not gonna get a lot of settlement in here. What you are gonna be able to see here is where you're getting anything that gets through. But typically, anything that gets through in your lower storm events is gonna be caught in our planning bed. And that's where your majority of your constituents are, is that first flush. And this is designed to handle an inch of runoff from our entire site before it even starts to overflow. So,
Can I ask, why did you put in the yellow, what are they called, storm tech or what are they?
they're called storm tech chambers, but there's a lot of manufacturers, but yeah, these things here.
What's the benefit of having them instead of like a French drain or some other
Right.
just porous soil or porous gravel that's under?
Yeah, these things here give us a ton of volume compared to like a stone. When we pair them with stone, we got 6 inches of stone underneath and over top. Your volume goes up considerably for storage purposes. So we wanted that extra volume, and then also for cleaning purposes. When these things fill up, you can see we kind of have all these drains go into one row. So we have this one isolator row, we call it. So any kind of sediment and everything like that, we can clean, and this is where you're going to see it. And it's set up. So this one row, this center row, is kind of our row it's an isolator row. When you come in, we're going to clean this. We're going to water jet this out. And that's easier. So if you had stone or anything like that, it would kind of be spread more out throughout. You really have to replace the whole stone when you start to get a lot of sediment, road sands, all that stuff that gets into this basin. So kind of two reasons. A lot more storage in the storm tanks, and then B, it's a little easier to maintain, trying to keep that one isolated.
Great.
Thank you.
Okay, well, thanks very much, Mike. I think that was a particularly inspiring presentation in the sense that, you know, academics can we can sit around in our offices and we can design these things and we can theorize and we can write the equations, the relevant equations, but in fact, these are the guys who actually go out and turn a vacant lot into something that actually is working. Yes, Ed?
I'm gonna offer a historical footnote about the site. So just in case anyone in the room isn't aware. So this is the site where Smith Corona made typewriters on the banks of the Erie Canal. And the factory goes back to 1902. And you can maybe imagine, you know, if it's 1910 and it's a Friday afternoon and you're shutting a plant down, how they would dispose of used oils from the machine room where they were, you know, cutting and plating metal. So there are a variety of contaminants known to be in the ground that actually there was remediation that was done of the site to meet the requirements of the DEC. But we're stewards of the site, trying to maintain what's known and not have it move into the watershed. And then the second comment about the sycamore. So when we selected this site, we have stakeholders in our community who informed us that they were going to watch that tree, and that it was our job to maintain this 100-year-old tree on the site. So we lovingly cared for it all the way along. And when we hired the designers to design this facility, actually their first instinct was to take it down, and we said we really, it was important to the community that we wanted this witness tree to be maintained on the site. So they accommodated our request and designed around it.
I think that's great. There was no EPA in 1910.
Do we have any data on the actual reduction, or is there any reduction in the overflows? I mean, that's the objective, is to reduce the stored overflow. We have a lot of data about how much water we captured. But what about the overflows? Have they, do we have any data there?
Is that tee up, Dave?
So in fact, I mean, this is of course the million-dollar question. And what several people around Syracuse are trying to do is to document what is that reduction. I guess that eventually, we meaning everybody in Onondaga County, we will be required to show that the CSOs have been reduced by 95% by 2018. And right now, what several individuals are doing is gearing up to do monitoring at lots of these sites to be able to make estimates of, gee, how much stormwater are we capturing here, how much are we capturing there. Some of these sites are going to be very important in that bottom line number. For example, the constructed wetlands located out over by the zoo is going to be an extremely important experiment. And there will be measurements made over there. There are measurements made on the green roof here on the COE. There are measurements being made at the On Center. And we're also going to hear about some measurements that are planned for areas all around Syracuse that will again help identify how much stormwater was being captured and how much the overflow is being reduced.
So about that outflow that is shown on the first slide into the creek by the creek walk. The first
Oh,
slide,
yes.
that's supposed to be a major overflow point. Is that being monitored?
Dave, do you want to address that one, or?
I can address them.
Yes.
So I will take the bold position of saying, we don't know. Okay. And the reason that we don't know is that it's difficult to measure in-pipe discharge when the pipe is also carrying solids that will obfuscate your measurement. So then if you want to measure a infectious material, then it has to be non-contact, right? And if you're measuring a lot of discharge, then usually there's chunks. And so if you put your instrument down there, the point you want to measure most is when it's high discharge, and that's when there's the most chunks, beating your instrument to death. So I think that there are a few different consulting engineering firms that have received contracts to go out and measure at critical points in the CSO infrastructure. And I think that the results from that have been more challenging than the monitoring bodies consider. Do exactly the consider. Secondly, there's a huge amount of uncertainty in measuring discharge, especially when you get to high flows. Third, if you want to go and measure the difference in discharge in Onondaga Creek due to contribution by the city, you should recognize that the city's only going to contribute about 10% to the discharge because most of it's coming from that honking big watershed. And it's subject to the same thing we are. So then there's a lot of error in the method by subtraction. I have some ideas about how to do it, but I'm not telling. So I think that there are ways to get at the question of the change in contribution. The method that's currently being pursued is primarily through modeling, looking at the change in predicted discharge through the EPA swim model. And that's a relatively sophisticated, spatially distributed, process. And it then requires also then have spatially distributed information, which means that CHGML has to downcast the next red radar grid over Syracuse and then ground truth that from reflectivity to actual ground surface precipitation, uncertainty. Welcome to hydrology. That's the way it is. So we will not have a black and white hard answer. There will be various estimates, all with error bars, and that's where the lawyers will come in. It's like that.
So this is actually a perfect segue into our third speaker, who is in fact Dave Chandler. So in fact, Dave is an associate professor in the Department of Civil and Environmental Engineering up at SU on the main campus. And I have to tell a little story about Dave, because we've done a lot of work together. So when I first came to SU and I met Dave, we started talking a little bit about some of Dave's work and the interest that Onondaga County has in hydrology. And I learned that Dave was a card-carrying hydrologist, in fact, with his PhD degree from Cornell. And then Charlie Driscoll, who's another very eminent faculty member in our department, mentioned to me, said, "Say, Cliff, just so that you know, Dave Chandler is not a permanent faculty member in our department. He's a professor of practice, and in fact, his contract's going to be up for yet another renewal, and we don't know if it's going to be renewed." And at that point, Charlie and I then realized that we had a job to do, which is making sure that this individual, who's so essential to our program, would in fact get a permanent position. And I'm really happy to say that the new dean of engineering, Laura Steinberg, was actually approved of Dave's transfer over to a tenure-track faculty position, which he now is. And in fact, his tenure package is now, as we speak, being evaluated. So we are actually very close to our target of getting Dave to be a permanent member of our faculty. I can't imagine doing any of this work without having a resident expert hydrologist on our campus. And fortunately, we are now very, very close to achieving that. So with that, let's welcome Dave.
So prior to coming to Syracuse, I spent most of my time doing either agricultural or wildland hydrology. And when I came to Syracuse, I recalled the small New Yorker cartoon on the back of my advisor's door, which was mostly open, so you seldom saw the cartoon. And it was Christopher Columbus standing on Manhattan Island looking out saying, "I see potential infrastructure." So then I come to Syracuse and I think, oh, this is great. I see potential green infrastructure, because I came just at the time when the building boom was going on. And so I thought to myself, well, this is great. It's a constrained system rather than the large natural systems that I'm accustomed to, so this should be duck soup. Yeah, that wasn't really cute. So I'd like to pass something.
Either one, whatever.
I'd like to pass something around while I'm talking, and you can fiddle it if you like. So this is a $300 sensor that will measure pressure for any sort of fluid, because it's well protected by a. This one's broken, so I took it apart. So this is the real deal here. So it has a wheatstone bridge here underneath the thick film, plastered onto a thick piece of ceramic. It's got a whole bunch of electronics that have been miniaturized so that it can collect 15-minute data for about 7 months. All using this little tiny purple battery. The battery lasts 5 years. And then it has a little optical interface here, so it never really ever has to use anything electrical. You can just plug it into your socket, and it will give bits and bytes through flashes and download your data, all for less than $300. Things have changed in the world of environmental sensing. So our friends at On-Site Computing are. I bring this up because the the reps from the company on Site Computing and Make came and visited me recently, and I said, oh, there's a huge market in urban environments. All you need to do is this and this and this. And they're working on a new model for this that is a low power Bluetooth application, and you can just walk by with your device and it will download the pressure sensor history from your device that's 10 feet underground. So I'll pass this around, you can play with it. Stay listening to me.
You dropped the piece.
Oh yeah. Those parts. Okay, put all the parts together. Okay, so this, I've been under a lot of time constraints lately, and so this is a little bit of a hurried presentation, but the point of my presentation is to focus on the green infrastructure outside, and if you haven't looked from the second or third floor out onto the wasteland there that is adjacent to the new green infrastructure, then really the punchline for my presentation is to get at what we have previously conceived of as the plan, which is a little bit at variance with the current plan. So, what about that? Okay. Whoa. Let's go to the top. Yeah, good. Okay, so if we look at the Center of Excellence during construction, this is what we saw. And I think it's useful to go back to the beginning to think about what the site was like before we started adding any of the infrastructure. And my impression is that there's this, so I put up this building here, and then there's a lot of construction lot around here. And please correct me if I'm wrong. My impression is that there's a pretty good hexavalent chromium plume underneath here.
That's correct.
Yeah. Now we're talking about the brownfield problem. Okay? Let's not forget about that when we start messing with the hydrology. So there's a big brownfield that we're parked on top of, and there's a few wells, right? So there were some monitoring and pump and treat, or just monitoring?
Monitoring.
So there's some monitoring wells to see which direction the plume was moving. Okay, because we would like that not to move very far. Fast forward to the semi-completed landscaping, and we have the beautiful part that we like, and then we have what looks like Wyoming within this fence, more or less, to me. And once again, let's not forget about that. I like to think about it as the devil is in the details adjacent to the sacred tree. Yin yang. Very nice. Okay. I also like to think about the fact that in many places where there have been toxic plumes, or especially with metals, the large deciduous or coniferous vegetation has heavy capacity to suck a lot of that up into its wood. So we may be getting some remediation effect out of this tree. I think it would be useful to get a tree core of that thing and test it for chromium. If it's there, maybe we should think about some more trees. So I cobbled this together from the runoff contributing area plan design made by the people at CH2 on Hill and County. So this is based on I believe, this is, and please correct me if I'm wrong, this is based on an aerial LiDAR survey of the city to get to make a digital elevation model from which we can then determine which way the water is flowing. You will note that this blue hatched area really did not consider that any runoff from this part, presumably because that was considered to be a separate project. So all of the runoff from across the street and that would come from the midpoint down the street, and the midline of the street is considered to contribute to East Washington Street. Since I'm here to talk about the East Washington Street part of the project, then I think it's worth bearing that in mind, and that that East Washington Street is not, for the purposes of the East Washington Street Green Street project, considered to have a contributing area from 109. Don't be afraid. So what this is the East Washington Street plans split because it's too long to fit on a piece of paper. So this part connects on the here. It's dashed lines. That's the and so so then if you look at this system, then there's a break. And that's the sacred tree, because the existing project couldn't go through the tree, so I had to stop. So then what I show here with red lines are the subterranean drain tiles that are underneath the green infrastructure, so that'd be the bioswale on this side of the street, and the large brick pavers on the other side of the street, and also the bioswale on the other side of the sidewalk from the brick pavers on the other side of the street. If you're not sure what I'm talking about, I don't mind if you stand up and go look out the window. If you haven't paid attention to what's going on out there, it will provide you a lot of context. So please go look if you aren't sure what I'm talking about. Okay, so what do we have? We have water running in from those streets and area over there into a catch basin, which was historically routed this way, and into a large catch basin here. So there's a manhole here. We have all the water that's coming down through the bioswale on this side of the street that is east of the sacred tree, moving into this catch basin, and we have the water that's moving from the end of the bioswale on the other street, moving here, and there's another tile underneath the porous bricks that comes to this point. Actually, this is not the as-built drawing. This got changed around a little bit. So I indicate our points of measurement on this whole system with green dots. So the intact version of the sensor that I passed around, we have logging in the bottom of catch basins here. So this is actually one catch basin with a weir in it. We'll get to that in a minute. And this is a catch basin with a weir in it. This is a clean out, and this is another clean out at the head of the system. So what we'd like to understand is what's the total storage in these systems, and how effective they are for capturing runoff and storing runoff after particular types of rain events. I don't want to go into that too much because it will take forever. Good. So then I mentioned that there's weirs. So then if we think about that pipe that I showed in plan view a minute ago as a red line, basically those pipes are moving through the gravel section of the ditch. And there's some planting material on top of the gravel. I used to think that green infrastructure systems were going to be complicated until I saw many of them being built in Syracuse. And here's my philosophy for how to build green infrastructure. You find a place with soils that hold a lot of water and don't have much room for capture, and you dig them out. That gives you a big hole in the ground. You fill that hole up with rocks, because there's a lot of pore space in rocks. You put a drain in the middle of the rocks so that the water can move easily from end to end. And then you cover it up with something. You've got a few choices. You can cover it up with porous asphalt, porous concrete, bricks, or dirt with some plants in it. There, now you can design green infrastructure, not that hard. There's a little bit of that. So, but really not that complicated. So then we started looking at these systems. I thought, it was so simple, but it turns out that sometimes the hydraulics dominate. So let's discuss how do we keep the water in the system and how do we get rid of the water when it's full. So typically, the way that the system works is that you would like the green infrastructure to fill up, but you don't want it to get too full. Because if it gets too full, then you just have a flood problem. Or if it gets too full and stays full, then you saturate the root zone for all your plants and you kill them and you have to replant them. That's also not good. So then there's a defined level which is considered full, and within the catch basin there's a weir, so a dam that's built to overflow when it's too full. So then the water comes in, it has to go over the weir to the outlet. So that's the tricky part. So we've been monitoring behind the weirs, because if we monitor behind the weir, then we get the total, we can calculate the total storage in the system, and we can calculate the rate at which the water leaves storage, presuming that the water level in the whole system stays relatively at level during the time of discharge. The water surface in these systems is not level when they're recharging, because they're recharging at discrete points, and there is then some head gradient through the system. That's interesting because what we've observed in our measurements in several systems, which is quite unexpected to me, is that that if you have a really high flux event, and I've observed this here, so if it's raining cats and dogs, that's what I mean by a high flux event, then you get lots of runoff, and the runoff runs quickly off the side, and despite that being sand out there, the top surface layer's got a lot of organic material in it, so it's part sand, part hydrophobic, and it does not infiltrate as fast as you would think. So then, what's it do? It goes in the dome riser. So you get a lot of flow in the dome riser, straight down to the pipe, down to the end of the weir. Catch basin, there's a hydraulic effect. Catch basin fills largely up to the top of the weir, and then within minutes, back down. That was not how I expected it to work, but we see this at a few different places, especially where you have a steep gradient in your drain tile. So hydraulic effects of the weir are a big deal and unexpected. Similarly, there's when you get that effect, there's a lot of opportunity for displacement of sediment into the filter bags that's hanging here in the dome riser. Maintenance will be the issue. Success and failure of the Save the Rain program will depend strictly on maintenance, in my view. I've been looking in a lot of catch basins, and I've found a lot of schmutz. Many of the filter bags are changed with sufficient infrequency to have saplings in them. I think that it'd be really useful to get the Onondaga Youth Corps guys out there fixing that problem. Okay, so the other place we put sensors is we put them down in these cleanouts. Okay, so most systems have cleanouts, so somewhere near the end of the pipe, it would be useful if you could get your hose down in there and wash it out. So there's two types of places that we use sensors. Here's my one data slide. Okay. So if you look at the what happened between May and the end of June, out front here, then we got one event where the water got almost up to the weir crest. It got over the weir notch, so we have a notch weir. There's a notch down at the bottom, and it gets wider as you go up. So this is the sole event during that period for which there was any discharge to the stormwater system. So in terms of thinking about how much reduction there is, I think it's useful to consider that this was the only storm event that the street contributed to the storm sewer system. So I think that's a really positive thing. When we started monitoring, then I was thinking, oh, maybe these are not designed to handle big enough events, right? So what's going to happen when, with a change in rainfall intensity and depth due to climate change, which is well documented, or is the city going to be invested in all of this green infrastructure, and it's just going to get bowled over by climate, right? I'm not so concerned about that anymore. Now, my current opinion is that engineers put a 50% safety factor on just about everything. So most of these are actually oversized. So it's a lot easier to build more stuff in one place than to distribute the same amount of storage across lots of places, largely due to site access and also due to the nature of engineering contracting. So there's a couple of things that support the idea of overbuilding, and I think that my expectation is that we will find that a lot of the green infrastructure around Syracuse has excess capacity. But back to our site here, so we put in all this infrastructure here, and then there's the secretary, and the lot's sitting there, and we need to deal with this runoff that's presumably going to run away from the building. Currently, the plan is to, as far as I recall, the plan is to put down some sort of impermeable liner so that the legally not a parking lot runoff does not infiltrate and move the hexavalent from where we don't want it to. But if you then put it into a groundwater, if you put it into a subsurface water mound over here, then that is not going to be disconnected from the water table over here. If we add to the water mounding from this site, with additional water mounding from this site, that will affect the groundwater over here. The groundwater vault is not very far away. That should be considered. Going back 3 years or more, we've had maybe 3 years. Is that right, Ed? 3 years we've been thinking about the Intermodal Transportation Center and
So we've been thinking about it since 2004. But you've been here for
I'm a relative newcomer. Okay, so just for an update or a back date, then the plan that we had considered for monitoring was to move the runoff to the end of the system and then run it all through a flume to the point where it would have an overflow to the sewer system. The idea being that two of the main challenges that we don't understand about green infrastructure performance is how it's going to withstand sediment and salt loading. It's not just about the water, it's about everything that comes with it. So, if you want to get sediment out, the people down there at the wastewater treatment facility already have a good way of doing that. You can put in a grit chamber at the head of your system and get your grit out. I suggest a point removal rather than something you have to dig up. This can be scooped up. at this point, it would be really handy for us to measure not only the amount of flow that's going into the system or coming off the parking lot, but also to understand what the chemistry of that is. Because then we can come over here underneath this is about where the real heart of the Intermodal Transportation Center is, right? Where the bike racks and the bus stop is. So our previous plan was to put in an additional point of sensing here so that we can understand the discharge past this point, storage in the system, and what sort of chemical transformations occurred along the length of our green infrastructure. That's where I thought we were going with this project, which is quite different from the current plan. So then this would also allow us to, if we flumed this, rather than allow it to sink into the ground, then we would have less perturbation of the local groundwater table, and our friend Hex the Devil maybe stays here in Wyoming where we like the devil, rather than moving over to Water Street. Yeah, that's what I wanted to say about the new plan.
Thanks, Dave. Okay, we have a few minutes for some questions and open discussion. So, yes.
So, to follow up on a couple of points that were made about the maintenance of the system and what Ed told us about the consent order, I'm wondering if the consent order deals with the maintenance obligation of the county, and is that maintenance obligation then distributed back to the property owners who have systems on their properties, or will that be a county or public responsibility going forward?
It is. So any of the public-private partnerships, the maintenance, in order to receive public support of a private project, you have to have a maintenance plan, and the county comes along for at least 10 years, twice a year with their little checklist and to make sure that the maintenance is being done. As well as anything that's built in the right-of-way in the city's obligated to maintain, and anything that's in the county property, I think the county is working largely through their own staff and through the Onondaga Earth Board to maintain.
Yeah,
Actually, I'd like to make a contribution to that question. So there's a lot of the green infrastructure that's been built in Syracuse is actually forest pavement. And I just had a master's student complete his thesis on evaluation of the permeability of forest pavement around Syracuse. And one of his primary recommendations was that it would be useful to build in sections of porous pavement that act as a fuse. So basically they can, so if you pre-filter, you recognize that there's some section of your porous pavement that you're going to sacrifice and replace, then that's an awful lot easier than having to dig things up. Because replacing pavement is not that hard. So, and pavement makes from its results, it makes a demonstrably good filter. So there's a lot of fines accumulation in there. Secondly, you don't want to build that out of concrete because it just doesn't work with the salt. Pretty much all of the porous concrete is gone or turned into sandbox.
We had another question. Yes.
The monitor, I was wondering if you could describe how and where that gets set up.
Oh, well, we could
The
go
sensor,
out. Yeah, sure, we can go outside, I should show you. Basically, we put up a 2-inch pipe down the catch basin. If not, then we just tie a tether, a piece of nylon string onto it, and let it lay on the bottom. It's weighted so that it will always find its own level. And they're environmentally resistant. They can't freeze and fail, so we can leave it in there year round. And it just ticks away and measures temperature and pressure every 15 minutes. If there's a lot of discharge in the catch basin, then it'll rock around a little bit, but it's only going to introduce an error of less than half a centimeter, which is probably small considered to the triplets in the catch basin depth.
Yes, Lisa.
I guess this is a question for Khris. It's arguably Syracuse has the highest capital spending per capita on green infrastructure, but I think the concerns that you brought up about maintenance and how things get clogged up, no matter how you over-engineer them, if they're clogged up like we see around a lot, we see sandbags in places where things have been designed. And granted, nothing's perfect because a lot of these projects are experiments and they're a learning laboratory, let's say. But at the same time, the maintenance and the management thereof and a financing plan to do so is critically important. So even though the city might be required to maintain these facilities, there's evidence that there is not. Now, nothing's perfect, nothing's perfect. But what kind of management, maintenance, and financing plan is there to do so? Because there are so many capital improvement projects here. We all want them to succeed. They all need to be monitored properly. But when you look around the country, for 30 plus years now, other communities have been putting storm drainage utilities in place. They've been hiring professional staff. They're not dependent on an overworked public works department that has to do everything. So is there some planning going on to actually take care of these matters so that we do have a long-term financing plan as well as maintenance?
I was only a contractor to the county, so I speak from my limited knowledge. And so one thing, a challenge, and we had the first ever New York State Green Infrastructure Summit actually in this room several weeks ago, and a challenge that was identified by a number of communities is that you cannot finance, you cannot bond or take out loans for operations and maintenance, so that you have to find money within your existing budget. Some folks are finding that to be a challenge. I don't know that that's the case for Onondaga County. There is a plan for the county to do long-term maintenance and operations for green infrastructure. They do recognize they can't do it with their existing staff. They're beginning to contract. They have been contracting with the Earth Corps and others. CH2M Hill, which has been their project manager design firm, has been going around to all the private projects and doing the investigations. The onus on the private projects, which is more than half of the projects, is on that owner. The learning curve, particularly for the city DPW, and I live in the city and I'm an ambassador for the city, has been a steep learning curve. But to be fair, most of these projects are less than 2 years old. There are none that are older than 4 years. And I think that going through a full cycle of plowing and salting and cleaning out grates and vacuuming, it's going to take a couple of years to really bring everybody up to speed. I think we're getting there quickly.
But how is that being financed?
We cannot take out loans, we cannot bond for it, so it's coming out of wastewater fees.
Ed's got a comment.
Yeah, so one of the interesting things about the installation of green infrastructure in Onondaga County is that there was a baseline design, right? So there was the amended consent judgment, and there was a totally gray solution that was designed. So the plant in the trolley lot, the plant in Midland, the other plants that were designed. So that's actually the base case. And in that base case, there would have been operations and maintenance of the gray infrastructure, right? So there was a capital cost for the baseline design, and there was an O&M cost for the baseline design. So now the green infrastructure solution, variation, now it's a combination of green and gray. So has anybody done the calculation of what's the delta in capital cost? I believe it's less, right? So the green infrastructure gray solution that's now in place, I believe that so this is my belief. I believe the capital investment is less. And has anybody done what the O&M is? Because there was an O&M, there was O&M before, right?
There have been some kind of extrapolated projections of green O&M versus gray O&M, and green's really got the gray beat because there's no energy input. The labor does change, but there's not a lot of, as these large concrete facilities and underground pipes get older, they require more and more expensive upkeep, whereas, the worst case scenario is you mill and pave, or you tear up a porous asphalt parking lot and you put it back down, or you come through and you pull up this bioswale and you lay it back down. You may not be doing that very often, if ever.
You know, Ed, there's I think another factor in here that I think brings your question, maybe it adds a whole lot of uncertainty bars to the question that you're asking. You may be aware that when the Midland plant was being designed and sent out for bids, there were a number of bids received, and one of those bids was chosen and the construction started. And in fact, the cost of the Midland plant ended up far exceeding by a huge amount what those initial bids were. So I think the lesson in that is, yes, we can make projections on what all the capital costs are for these RTFs, but in fact, the true costs may be a whole lot different than what the design costs are.
And that cost of Midland is about the total of all of the green improvements in the Save the Rain program. So the cost of that one plant is about the same as all the green infrastructure that we've been doing.
And I think it's especially true, Chris, I'm sure you back this up, that in fact, this is, as Lisa was saying, an experiment in progress, and that I think we look 10 years down the road and we're gonna know a whole lot more about the operating and maintenance costs of the green infrastructure than we know now. And what we're doing now is making educated guesses. So I think the jury's still out on the original point.
So I'd like to build on what Cliff has said, and that is that, some of my statements might have seemed a little bit antagonistic, potentially. And that's primarily because I view my role as an academic to push the technology and to identify where the potential failures are, because this is still relatively new technology. And we have to be honest about where it's working well and where it's failing. So I think that, I've discussed this with other colleagues interested in green infrastructure from basically up and down the East Coast. And there's a general agreement that the sediment problem has not been well solved, and that filter bags are not the answer. So at the time the generation of green infrastructure we got, filter bags were the available answer. But now they're, that's about as, I guess, practical as trying to put a filter bag on the head end of your treatment facility. So my expectation is that in response to the difficulties in maintenance generated by the filters at inlets, we'll start to see new technologies. I mean, they could be cyclonic. There are other types of technologies, but they weren't adopted yet.
I think we just about reached
last
the
one.
Oh, the last question. Oh, okay.
Have the last word.
So you had talked about, I guess you're focusing a lot on failures of the porous surface. You talked about studying like the sacrificial piece that plugs into place. It seems like there's not a lot been done in looking at the geotextile that's put in place on most of these, and when or if that ends up plugging.
I think that there's a wide variety of geotextiles, and so there will probably be some experimentation with that. I think the bigger problem actually with failures in the material under porous lots is contractors' lack of familiarity with piping through and like the collapse in the elephant plot up at the zoo. There was a lot of piping along through the gravel that ended up in reconsolidating underneath the paved surface and failure. So I don't think that I don't know that grade separating type geotextile will be, well, we'll see. But if it's already down it's already down at the bottom of the porous asphalt, it seems like the opportunity for internal sedimentation within that aggregate is probably greater than filtering it when you get down to the level of the geotextile. Runoff number is going to be really low moving down through that aggregate. It's going to be internal sedimentation.
All right, so Ed, would you like the last word?
So I'm gonna thank Cliff and Chris and Michael and Dave, and thank everybody for coming. So there's some refreshments outside.